Excellent, I'll get started. Well, good afternoon, everyone. My name is Yannick, and you're here to hear about From Recipes to Results, Gousto's data journey. I've been invited here by DBT Labs. I'll be talking you through the past 18 months at Gousto, specifically about our analytics engineering team, some of the changes we've made, and how we've incorporated the DBT platform to do that. So the agenda for today, I'll talk you through what is an analytics engineer and what they do at Gousto, our current data modeling setup, the organizational changes we've made recently, the infrastructure changes we've made recently, some of the modeling changes we've also made, and a bit about what we've learned on this journey. So, a bit about me. I started off my career in the civil service, on the civil service fast stream, on their commercial fast stream. I was there for about a year or so, and I met some pretty inspirational consultants from McKinsey, and then I decided to head off to the private sector. They inspired me with some flashy Tableau dashboards and some pivot tables, and I joined commercial aviation. I worked at British Airways and Qatar Airways in various commercial roles in pricing analytics and then deeper data analytics. More recently, I was at a scale-up called Echo. It's now called Lloyd's Direct. They're an online pharmacy, and they deliver prescription drugs to your home. I was there for about 3.5 years as the head of data. And more recently, I am the analytics engineering manager at Gousto, and I've been with the business for about 18 months or so. So that's a brief history to me and how I ended up at Gousto. A bit about Gousto. Finding your dinner piece. That's a corny line I got from the company website. What does Gousto do? Gousto is a meal delivery company. For the most part, on a Saturday morning, I arrive downstairs and there's a big red box on my front door, and it contains various ingredients, recipes I picked on the app the week before. It was founded in 2012 by an ex-investment banker called Timo. We're based out in West London, near the Westfield. We're about 1,000 or so employees, 1,000 plus employees. And we have two large factories, one in Clay Lake and one in Warrington. Warrington is the newest, more automated one in between Manchester and Liverpool. We currently deliver packages of food in Ireland and in the UK. Typically, there are about 200 recipes on the app when you log in, which is pretty good. My favorite is the Korean bao buns, if ever you get a box. And in DBT currently, fun fact, we have about 800 or so DBT models currently live in DBT. So what does an analytics engineer do at Gousto? The analytics engineering role is a relatively new one. I'm pretty sure DBT coined the term, if I remember correctly. And it sits in between your data engineers and your analysts. How I describe it is that the analytics engineers, they bring the software engineering rigor that software engineering has to analytics. So it brings things like Git and version control, things like orchestration and automated testing. If I go back further in my career, when I first started as a data analyst, I had on-prem servers. I put my code in a SQL file. I emailed it to a colleague. That colleague then emailed it back to me. We weren't quite sure who made the changes. I'd lose my laptop, lose my SQL files. Working with version control, working with Git, having automated testing before we push code to production. All of these things mature the analytics space, and that's what the analytics engineer's job is to do. For the most part, at Gousto, the analytics engineers maintain the platform, so it means that the analysts purely focus on the insight and analytics. They're not worried about maintaining, versioning code, worrying about naming conventions, worrying about the infrastructure on the platform. That's all managed by the analytics engineers. And we're the go-between between the analysts and the data engineers, so the people that are producing the data and people that are using the data, because we speak both languages. We get technical enough to talk to data engineers, but yet we're close enough to the business to understand the analytical needs of the analysts. So where were we? When I first joined 18 months ago, we had a medallion data architecture. meaning we had a bronze, silver, and gold layer. The bronze layer being the raw outputs from our various data sources. The silver layer being that data deduped and maybe with some timestamps included. Nothing much happening there. And then our final layer is our serve layer, which is where your AEs get involved and they transform that data, give it business context, and present it to the business in a way they can use for dashboarding, reporting, and such things. Fun fact, at Gousto, we actually call these layers raw, cooked, and served, due to the fact that we're a food business. We had a centralized AE team. So that meant that the AEs sat in data platform, and we had various product teams within the business. Typically, they created tickets. They were sent over to the centralized group of AEs, and then in a priority order, we worked through those tickets. And we worked in a mono repo structure in dbt core. dbt core is the free version of dbt that is CLI based and takes place locally on your laptop. And we had all of our data models in one repository, so all 800 in one place. And I had a conversation with my VP of data soon after I joined, and our CTO, and they said, the infrastructure we have, the ways of working we have, they work today, but we don't think it's going to scale with the business where we want to go. So they said, have a think about these topics and get back to us with a plan as to how you're going to make changes to this. So one thing that was said to me that we needed was self-serve. I'm sure all of you have worked in a business and they said we want to have more self-serve data. I got told the exact same thing. We wanted to equip analysts with the ability to own the data models that were created and ship them. Because currently they weren't getting particularly involved in the data modeling. They were purely just recipients of modeled data. We wanted better and clearer data governance. We have a pretty strong data governance team, and they were unhappy with the way our data was governed. They didn't have good visibility of our tests. They weren't sure who owned what, and that needed clearing up. And again, a topic I'm sure all of you have heard all about from your CEOs, CTOs, VPs of data is AI and LLMs. How was our data ready for the future with AI and ChatGPT, Copilot, Gemini, etc.? So what did we do? So we started with shaping the organization, particularly our AEs, and then looked at scaling the platform. So the first thing we did is we changed the way our AEs worked. Previously, I explained that the AEs were in a centralized team, and the tickets came in centrally, and then they worked through them in a priority order. What we decided to do is change that. So we had the AEs embedded within the various product teams. What this meant is that the AEs were much closer to the actual analysts and the problems they were solving, and were able to get to solutions in a much quicker time from ideation to actually implementing the solutions, because there wasn't a go-between. The AEs and the AEs were involved in the conversations that were taking place and had full context of what the product teams were up to and what they were trying to change. And what we also have seen when making this change is that we have the analysts who were a bit detached from data modeling, feeling a lot more involved and feeling better ownership of the actual models that were being created on their behalf. And we got them more involved in that process. We also moved from dbt core to dbt platform. One of the most difficult things about dbt core for the analyst community, who are less technical than the AEs or data engineers, was onboarding. The onboarding process for dbt core is quite technical. It requires decent understanding of the CLI, of Git commands, Python versioning, among other things. And that just wasn't suitable for our analysts. And it used to take about 6 to 8 hours in practice of time to get them onboarded and set up. And that wasn't a particularly pleasant onboarding experience for the analysts. And what we found is that because that onboarding experience wasn't particularly pleasant, they didn't then use the tool as much as they could have. So we moved to dbt platform, and that has a graphical user interface. You have single sign-on by your Gmail account. So within 15 minutes, by clicking, they were able to make use of dbt. It abstracted away the CLI and allowed them to use a graphical user interface. It allowed them to focus on the modeling, so actually making changes to the data and not on the infrastructure and why their Python version wasn't correct or why they were getting into a Git hole. So therefore, they were doing what they were good at, which was getting insight and adding value to our data models. The other benefit also was that our data modeling wasn't particularly visible. So our VP of data, he's quite high up, doesn't get involved too much in the detail. He wasn't exactly clear on what we were doing. And what dbt Cloud meant was that he was able to log in, see the orchestration, see the models, see the lineage, and it made what was somewhat abstract and nebulous something quite tangible for our data leadership team. The next thing we're doing, which we've just started on, is moving towards mesh architecture. It's something we've spoken about since I joined the business about 18 months ago. But what was stopping us was the infrastructure that would have to be in place to enable a mesh architecture. In dbt core, all of the orchestration, Git versioning, CI/CD, Python versioning would have had to be replicated in multiple repositories, maybe 7 or 8 times. And with an AE team of 5, that would have been probably 200% of our time just managing the infrastructure. With dbt Cloud, much of that is automated in the platform, so we thought it would be a good time to start exploring using a dbt mesh. We'll be moving to an entity-first design, so moving away from massive wide tables. I'll give an example. Our orders table was 184 columns wide and had about 20 different data sources being joined into it. That made for easy querying for data users, because there was one table that contained everything from your order ID to your onboarding platform, to how many orders you'd made, to what factory what your order was shipped from. But what it meant is we had massive tables that were points of failure in our system, and that wasn't good. They were also relatively inefficient to query, inefficient to load, because of the number of joins that we had to create in those tables. So what we wanted to do is to federate our data model and create business concepts. So we have data entities, with each entity representing a business concept, and normalizing those tables. We wanted also to have better ownership. So rather than having a mass of 800 models that were spread around, we wanted to federate that and have entities and entity groups that are related to different parts of our business. And then, I mentioned data governance earlier, have better ownership and assigned ownership for each entity group. This is a visual example of a traditional data model. It sprawls. Typically, you start small as a startup with 15 models, typically a founding team of data professionals. Everyone understands what's been built. Then over time, a new use case, the business changes the operational model, you need new tables, someone leaves, they create a new data model that's a duplicate of another data model, and it grows and it grows and it grows. And we have something similar to this, but with 800 individual nodes. What we're moving towards is a data mesh, where we split up what you saw earlier into separate dbt projects. So for example, we'd have marketing, sales, finance. And what this does is on the next slide I'll show you the benefits we anticipate from this, but the key thing I can show on screen here is the fact that in the prior slide, what you'll see is an interconnected mess of tables. And if one table pretty far upstream fails, that would knock out 20, 30, 40% of our tables on our daily run. So we wake up in the morning, we'd have PagerDuty alerts, people saying, I haven't got my data, and it's because one data source really far upstream has taken out most of our data infrastructure for the day. And what you can see here is, because we federated that, if there is a failure in one of the marketing data models, then that failure is localized to the marketing data. It won't affect the sales data or the finance data, which means that the blast radius for any failures is greatly reduced, and we have less complaints from stakeholders, and less likely that my VP is knocking on my Slack saying, "Why is our data out for the day?" So I mentioned the robustness that this brings. It's also easier to find what you need. So rather than having to sift through 800 different models seemingly at random, if you're looking for a finance table, well, you go to the finance project. You take a look in there, you find the model you want. It also future-proofs our design. So the data mesh allows us to modularize our data. And what that means is that, I mentioned earlier we had these massive wide tables, 184 columns wide, 20 joins in there. What that meant is that if, say, the granularity of an order changed in the business, we had to rework 20 different models that were joined into that table to make that one change to that granularity, to that piece of granularity. When we federate our data and we have more normalized tables, such changes are much easier to make. We spent about 2 weeks trying to change the granularity of our orders table. Changing the granularity of your tables, as you probably know, is probably one of the most difficult things you can do because it can damage your referential integrity and all of your joins. Lastly, what we're currently embarking on is enabling AI and self-serve. And what's the link between a data mesh and AI and self-serve? I'm going to keep referring back to that massive wide orders table because it really was a bugbear of mine. And the reason why is because when we tried to implement ChatGPT and feed it our data models, it didn't have the proper context and the relational understanding of what our various business entities were. And that's because we pre-joined the data and served it a massive wide table. And as we started to decouple our data and create the federated data estate, what we're able to do is create entities, groups of entities, and with that, define relationships between these entities. And therefore, when we ask questions of an LLM using a semantic layer, it's better able to understand that it isn't just one massive blob of data with a black box of SQL behind it. We can actually say that we have e-commerce data that has promo data, and that is related to some finance data via this primary key, and that was more easily interpreted by the AI tools we were using. We're pretty early on that journey, but we've had pretty good success so far with a proof of concept semantic layer that we've launched within our operational teams. And they've been using that to get better access and easier access to their data a lot more quickly than they had been. So what did we learn on this journey, making these changes? There are lots of technical things that we learned, right? I think that, we learned all about semantic layers. We learned about mesh being a thing. We learned about some of the new features that the DBT platform has that would improve our CI/CD. But I think the more powerful things are actually the soft things we learned. That the AE role needed definition and advocacy. The AE role, even within Gousto, who had AEs, I still often get the question, what do you do? Are you analysts? Are you data engineers? Somewhere in between? And it became clear that our customers, the analysts, weren't quite clear on the value we could add to them. And throughout that, I said, by having the AEs embedded within the product teams, having them working side by side with the analysts, talking them through how to make their modeling more efficient, implementing additional testing to their code to make it more reliable and more robust, teaching them about DBT as a tool, about the benefits it could bring to the analyst community. That brought better understanding of what it is that the AEs do and did. What it also meant was, I mentioned earlier, in that by going through this process, I was able to talk to my VP and my CTO about the benefits of good data modeling. Typically, the focus was on the big, flashy, new algorithms that the data science team were creating, the insights we were creating from funnels for customer retention. But behind that were some silent heroes, which are the AEs who were creating that data, who were ensuring it was accurate, ensuring that it was available on time, every time. And that wasn't necessarily that visible. The other thing was actually cost. That kind of brings a smile to the air of every CTO, which is, I have a massive Databricks cost. Why is it so large and why is it growing? And one of the things that going with the data mesh brought and having AEs sit more close to the analysts was ensuring that our modeling was a lot more efficient. There was lots of very inefficient joins, in particular lots of cross joins, which aren't good, that were exploding the size of our data. And having the AE sitting much closer to the analysts meant that we had better visibility of the code base that was being created, and could ensure that we had cheaper code that brought smiles to my superiors' eyes. Specialization, scales. In the old structure, you had analysts who were trying to set up a quite complex infrastructure with DBT core. And they were spending time getting lost in, as I mentioned, in trying to learn Bash, trying to learn about Python versions. And that wasn't what they were hired to do. They were hired to get insights from data and add value in that sense. And bringing in DBT platform enabled us to have the analysts focus on the value add and not the infrastructure, and allowed the AEs to focus purely on ensuring the platform was correct and ensuring data arrived where it needed to be. And when the analysts had to interact with DBT, it was via a user interface, and they weren't required to learn a new skill to get the insight from their data. And lastly, ownership. What's been great to see over the past 18 months is how the analysts have gotten way more involved in where their data comes from, because they can see it now. Before, it was locked behind the black box of a black and green screen in a CLI somewhere. And with DBT platform, they're able to see the lineage all the way through to the source systems. They're able to see all of the SQL code that goes into it. All of the testing is easy to see. They can see where it failed, when it failed, why it failed. And what that's meant is that they just feel more involved in the data they're using. And that's been bi-directional. It's meant that they've been able to give more context to the analytics engineers, and it's meant that we can better help them. And in that, they've just, as much of the AEs felt like it's their data and not data that they're just picking up from AEs. And it's meant for just a much better relationship across our data teams. That's me for today. I'll be, I believe, at L20, is that correct? Yes. If you have any questions for me, any technical questions, or to hear a bit more about what we've been doing at Gousto from a data perspective. And lastly, I think it's a quick plug for Coalesce taking place in Vegas. I believe if you scan that barcode, you'll get a link to the stream of the conference taking place. Thanks for joining. I hope you've enjoyed. Have a good afternoon.